Hi everyone, my name is Katie Kirk. I am an oceanographer with NOAA's National Ocean Service Center for Operational Oceanographic Products and Services called COOPS. It's also known as the Tides and Currents Office. Um, I am acting as the Deputy Chief Scientist right now, and I am also a project lead of the Charleston Harbor Tidal Current Survey. Although I am not from Charleston, I'm from Annapolis, Maryland, grew up sailing. I've sailed in the Charleston Race Week many times. It's a fantastic event. Honestly, I wish I was there with you all this weekend and getting ready to race. So with that, I'll get started. So COOPS, where I work, is the source for accurate, reliable, timely tides, water levels, currents, and other oceanographic data. We collect data and produce products to help support safe navigation primarily. We have a suite of different systems. Several of them are based on observing systems in that they collect data. So we have our tide gauges, which is our NOAA network. We have our ports, which are real-time water level, winds, currents, and a lot of pilot captains and the maritime industry rely on these real-time data to help plan their routes, especially in constricted harbors. NCOP is our National Current Observation Program. That's actually where I work, and I'm a project lead within NCOP. I run tidal current surveys all over the coastal U.S., and my most recent project was Charleston Harbor, which is why I'm here talking with you all today. We also have several forecasting systems, the first of which are our operational forecast systems. They provide a short-term, up to 48 hours, forecast of water levels, currents, water temperature, and salinity all over the coastal U.S. I'll talk a little bit later about the model that we are developing that will include Charleston and the whole southeast coast. We also have marine channel forecast systems that are primarily geared towards the navigation audience, and we also do coastal flood predictions like high tide flooding and other inundation related products. So again, I'm here to talk about NCOP, the current observation program that collected data in Charleston Harbor, and what those results are so you all can take that into account when you're racing this weekend. So here's a map showing all of our tide prediction stations, the yellow dots, and the current prediction stations, purple dots. So no matter what race course you're on this weekend, we have a prediction for you. So I'm going to start off by talking about Fort Sumter at the mouth of the harbor and Charleston Harbor Custom House Wharf, or the Battery, because there are similar or co-located tide prediction stations with current prediction stations, and I really want to show the difference and the relationship between the tides and currents. So to start on that note, just making sure that everybody is on the same page with terminology. When I talk about the tide, and I'm really talking about the vertical water level, the high tide and low tide, so that vertical change. And that tends to force the horizontal motion of the water, or the tidal current. So when I'm talking about current, I'm really talking about the horizontal speed of the water movement. When I say flooding current, I'm talking about the current flooding into the harbor and upriver. And ebbing current is ebbing out of the harbor and out the mouth. Slack current is between the flood and ebb tide, and it's really a timing, and it's when the current speed is roughly zero. So here we have tide predictions. This is at the Charleston Harbor gauge near the Battery, and we are coming off of a neap tide in the first quarter moon. We are coming up on a full moon. That will happen on the 12th, and that leads to a spring tide. When I say spring, I think of the water springs up. So the high water is a little bit higher than the neap time, and the low water is a little bit lower than the neap time. For the locals out there, you're going to come up on a even higher spring later this month. But again, your race weekend is here on this spring tide. When the water levels are a little bit higher, as they are in the spring tide, you're going to have slightly faster currents than you would during a neap tide. And for those locals out there, you might have some possible flooding, some high tide flooding. We do have a monthly flooding forecast that I'm happy to share with anybody who's interested in. So for, again, this weekend, you've got tides, 2 highs and 2 lows a day. So you have semi-diurnal tides, and those magnitudes of high tides are approximately the same, as you can see here in the figure. For Friday, for tomorrow, you're going to be starting out on a lowering tide. So you'll just pass the high, it'll be lowering out, you'll hit that low, and then it'll start flooding in again. Same with Saturday and same with Sunday. So your race committee has done a great job to time these tides in a way that, especially for the offshore class, y'all will be taking the tide out of the harbor and then turning around and riding the tide back into the harbor, hopefully. In looking at the spatial variability of tides at the Fort Sumter gauge, which again is near the mouth, versus Charleston Harbor Custom House Wharf, which is near the battery, the timing of the high and low tides are about equal. The magnitudes are slightly different, but frankly, for what you're concerned about this weekend, pretty negligible. So you can really look at either tide gauge. There's also a third tide prediction station, I actually should say. There's actually only one tide gauge there. Tide prediction station. It's going to give you similar results. That's not necessarily the case for currents. So here we're looking at the current magnitude or the speed, which is the y-axis on the right-hand side of the graph there. And we're looking at Fort Sumter, which is the darker orange and slightly larger magnitude curve, and Custom House Wharf, again, close to the battery, which is the slightly lighter yellowish orange with the lower magnitude. And here when we talk about speed, the positive numbers indicate flooding in, so currents flooding into the harbor. When you get around this dotted line of 0, that's when you have slack currents. Currents are about not moving. And then when you have negative speeds, you have an ebb current flowing out of the harbor. So you can see here the timing and magnitudes between these two stations is pretty different, right? So you have to make sure, depending on which course you're on, you're choosing the right current prediction station to look up the timing and the magnitudes of your currents here. So just zooming in for tomorrow, for an example, at the Fort Sumter gauge, again, the darker orange, you're going to experience max ebb around 11:30. About 20 minutes later, the currents will be reach your max ebb at Custom House Wharf. So about a 20-minute gap between the max ebbs between these two stations. The gap in timing of the max flood is more. It's over an hour. Hopefully at this point you're not on the water racing still, but this just goes to show that the timing between that max flood and max ebb and when the slack currents occur are different for each station, and a lot of that has to do with the tide coming in and being reflected and being channeled by the bathymetry and the topography, and that creates a unique signal for your particular location. So again, just make sure you're checking the right stations. I'll show that in a little bit. So again, Fort Sumter, the ebbs and floods happen a little bit earlier than they do near Custom House Wharf. So again, all those purple dots are our current prediction stations where you can go and look at the exact timing. So if you're on courses 1, 2, and 3, you can find your specific station there. Now I just want to talk about the relationship between the tides and currents. So we're looking at the water level in blue, which is on the left hand of the y-axis there, and it's reaching not quite 6 feet. Again, we're coming up on a spring tide, and the orange line there is the current speed, and the y-axis is on the right side. Again, positive numbers are flood, negative numbers are ebb. And zooming in for tomorrow, for example, the max ebb at Fort Sumter, again near the mouth of the harbor, aligns with the water level passing the mid-water level, but we haven't reached the low tide yet. And the low tide doesn't come for another couple hours. So again, you can't just check the tides, you got to check the currents as well, because that timing doesn't quite align. A lot of times people assume that max ebb is happening at that low tide, and that's true for certain areas, but not here. That tidal characteristic and how the harbor is shaped and the bathymetry all plays into the characteristics of the tides and currents and that relationship together. So your low tide is actually happening after the max ebb on a slightly weaker magnitude there. Your max flood is happening at approximately mid-water level, and your high tide, again, hopefully you're off the water and don't have to worry about it, but your high tide again is happening coming up onto a slack tide. So it just goes to show it's more of a standing wave behavior for any people out there that are into the physics. Custom House Wharf is similar. You are going to have a max ebb several hours ahead of your low tide, and it's going to be past your mid-water level there. Your low tide then is coming back up again closer to slack, but we're not there yet. Your max flood is happening beyond your mid-water level, and your high tide again, hopefully you're off the water, don't have to worry about that, but your high tide will then be coming back down in magnitude of the currents and headed back towards slack. So again, here are all of our current prediction stations, the purple dots. We have plenty of them, so no matter what course you're on, we can find a station for you. And if I've plotted all of the maximum ebb tidal currents, and so all the arrows are scaled in size and color relative to the speed. So the larger the arrow and the redder it is, the faster the currents. And what you can see immediately for that offshore course, the jetties end right around where the color changes in the Google Earth image there, and around that orange arrow. Beyond the jetties, the currents start to get a little bit weaker. And this is really because these are current predictions generated only by the tides. And so there's some other influences happening farther offshore. So the tidally generated current is relatively weak out there. That being said, as you move up into the channel and closer to Fort Sumter, you have really strong currents. So you can think of all that water leaving the harbor. It has to go through that narrow inlet. And so the water speeds up and it gets kind of forced through the jetties. And so it's pretty straight. We call that rectilinear, where it's along the channel. And you notice this red arrow that kind of looks like it took a left turn or a right turn, actually. That is actually where there's a deep channel. You can see that in the nautical chart. So the currents really do get funneled and channel the bathymetry. So if you look at the nautical chart, you'll see that most of the currents follow the lines, the topographic lines there, and so that right arrow shows and actually follows the channel bathymetry here. Otherwise, most of the currents are just flowing out of that main navigational channel. There are really large ships that come through here, so just be careful. You don't want to be that boat that's in the way. And so moving on to currents in the harbor. There is a southern navigational channel and a northern navigational channel, and that is where you're going to find the slightly stronger currents, especially on the ebb. You can see that with the orange and red arrows coming out of the Ashley River and the orange and red arrows coming out of the Cooper and Wando River coming down here. So again, those align with the navigational channel. In general, currents tend to be faster in deeper areas like the channel. They tend to be a little bit slower over shallower areas due to bottom friction. On the ebb, we can also see right behind Castle Pinckney, or Shawley, you can see the yellow arrow gets shaded or shadowed a little bit. So that flow is coming out around Castle Pinckney. It does flow right over middle ground, so race course 2 and 3 do expect to have some ebbing currents come right over middle ground, but right behind Castle Pinckney you will have a little bit of a shadow. So here are just general course circles, and here you can see the actual bathymetry. So you've got the currents flowing out of the Ashley River following that navigational channel that are strong, and again also on the northern navigational channel as well. And then you've got currents flowing out of the Cooper River over middle ground with the smaller velocities happening right behind Chutes Folly Island or Castle Pinckney. 3. And then for course 4, you're in an interesting spot because it's where the Cooper and the Wando come together and converge. And you can see that a little bit in the Google Earth image, that there's a little bit of mixing there. Currents are pretty strong and steady throughout this whole area. Again, these currents are tidally driven, is what I'm showing you. This is not taking into account river off flow. So if it if you guys just had a rain event and there might be some riverine effects, this is not taking into account that. So the current could be stronger if you have a lot of outflow from the river. It could be weaker if you don't have as much outflow. So just keep that in mind. And then for the flood, it's obviously the opposite. We're flooding in. Again, currents are very strong at the mouth where a lot of water is getting forced into a small area. So right around Fort Sumter, you're going to have strong currents. Other than that, water is going to flow in, go up the Ashley, up the Cooper and Wando, and it will flush over middle ground as well. You can see that, again, slightly stronger currents in the northern channel, headed up towards the Cooper and Wando versus in the Ashley. But overall, it's pretty straightforward. The magnitudes of the flood are much lower than the ebb, so I really wanted to focus on the ebb currents, and I think you guys can handle the flood current. So wanted to show, if you go to our website, tidesandcurrents.noaa.gov, gotta get that right. You can click on the map, click on South Carolina, and you'll see up here this box on the left. Click to Advanced and choose Tidal Currents, or Current Predictions, Current Predictions. You will then see this map. You can then pick from these stations to see current predictions at each station. And that looks like this here, where I've chosen Castle Pinckney. This is a station you might want to use for course number 1, for example. And you'll see a graph with, again, positive speeds are floods, negative speeds are ebbs. You can see immediately that the magnitudes of the floods are about a half a knot, where the magnitudes of the ebbs reach up to 2 knots. And on the right-hand side, you'll see the timing of the maximum ebb, slack tide, the maximum flood. And so, for example, here's the maximum ebb for tomorrow, which aligns with that point on the graph right there, and then again for the next day. So you can look at all this and choose which station you want to use. Again, tidesandcurrents.noaa.gov, and then click on the map, and on that advanced screen, choose current predictions. So I wanted to take a little bit of time to talk about tide lines and salt fronts. So on this Google Earth image, you can actually see a tide line right here, which is great. So this occurs when you have 2 bodies of water mixing, and it creates a white foamy line. And when you're actually out in the water, you can see a difference in the color. So there's a darker color and a lighter color of water. So you can actually see that. That should indicate to you that the tide is changing or has already started to change. And the differences in colors and the mixing can be because 2 different types of water bodies are mixing together. It could be ebbing out the Ashley River while it's flooding in up the North Navigational Channel still. So the timing spatially, like we talked about before with the difference in timing of the ebb and the flood between the 2 stations, it could take some time for the entire harbor to be on an ebb and the entire harbor to be on a flood tide. So while that's happening, you can have this fresh water that's buoyant and light and less dense come out of a river that floats on top of the oceanic water that is saltier and heavier and denser. And that leads to these 2 water bodies colliding and creating this mixing. And so that's what you're seeing at the surface is basically a reflection of that. Sail through it, it's fine. If for whatever reason you're sailing along it, you might notice your keel is feeling one type of force and your hull at the surface is feeling another. You just sail through it. It'll be fine. But that should be an indication to you the tide is changing, the currents are changing, and on one side of the line it might be doing something, and on the other it might be doing something else. So far I've been primarily talking about currents driven by the tides, just that vertical motion leads to that horizontal motion. But winds can also create currents, they can also create waves, and in our tidal current predictions, we don't account for winds. That's what numerical models are fantastic for, and there is something to be said about the winds that generate currents and waves typically generate larger waves when the wind speed is high. The wind speed is high for a long period of time, and the wind speed is high for a long period of time over a large area that's unobstructed or has a large fetch. So out in the open ocean, you're going to have huge fetch, and the wind speed can be really high for a really long period of time. That's going to create swell. And if you have any type of storm system, the swell will actually propagate ahead and out from the storm. And I think Shay talked earlier about a storm system rolling in. So you might start to see those swells come in, especially for the offshore group. Whereas in the harbor, the jetties do a pretty good job of dissipating some of that swell. And so you're going to probably have shorter, choppier waves with shorter periods and wavelengths. And you will definitely have shorter, choppier waves if the wind and the tidal currents are fighting one another. If they're not aligned, that could cause wind-generated currents against a tidal current. And so that convergence can lead to some choppy waves. But in general, the wind generates waves, whether they're short, choppy, or long swell, and usually the waves propagate in the direction of the winds, as you can see here in this figure. So given, of course, where we have windward lewards, you are typically fighting the waves and you're kind of beating against them when you're headed upwind. And a lot of times it feels like all your momentum is getting pulled out. And that's really due to the wave motion. Orbital velocity of the crest and the trough of the wave are opposing one another. They're actually working in opposite directions. So your bow and stern, depending on the size of the wave and depending on the size of the boat, of course, could be feeling opposite forcing, which feels like you're just stopping dead in the water. So that's the reason behind that. And then when you're going downwind, down wave, this same thing happens. The crest of the wave is feeling and headed in the opposite direction as the trough of the wave. And it's really the orbital velocity motion. So that's shown in this figure here. I hope none of you are sailing waves this large relative to your boat this weekend. So this is a very exaggerated figure. But here you can see that the wind and waves are pushing the stern forward down off the wave. And when that bow hits the trough, the wave motion is going in the opposite direction. It can actually cause the bow to get turned back up into the wind, leading to potentially a broach. So that's sometimes why you get some helm when you're driving downwind. So just be cognizant of that. That's what's causing it. You are surrounded by plenty of professional sailors who can talk to you about how to best drive through this. I just wanted to explain what's going on there. So we have a couple different exciting products that are coming soon. So I hope in future races we can talk more and show the actual products of these. First off is the Southeast Coastal Operational Forecast System, SEACOFS. It's a numerical hydrodynamic model. It covers a larger area spatially than our single individual points for tides or current predictions. It provides nowcast and forecast up to 48 hours of water level, currents, and those currents are driven by the tides, but also we incorporate the National Weather Service's wind forecast as well. So we can incorporate the winds and some non-tidal forcing to get a true sense of what's happening with the currents in near real time. Water salinity and water temperature. So you can see in the top figure on the left are operational forecast systems that cover most of the coastal U.S. And right now we're filling that gap that currently exists with the Southeast Coastal OFS, as you can see in the lower image, which covers from the Chesapeake Bay down through the Keys and up through Florida's Gulf Coast, and as well as Puerto Rico and the U.S. Virgin Islands. So right now it's currently in development. Our partners at VIMS, the Virginia Institute of Marine Sciences, shared with us this courtesy video showing some Charleston Harbor currents in the very preliminary stages of the model development. We're hoping that this gets fully developed, becomes operational in FY27, and the visualizations will improve, everything will improve. But that was just sort of a sneak peek of what's to come. Oh, I got two. Okay. Also, what's coming is updated tidal current predictions in Charleston Harbor and also actually Savannah River. A colleague of mine finished that tidal current survey. So Charleston Harbor was the project that I went out and collected data at all of these white dots and a few others that are actually off the screen. Collected data. We are going to update the tidal current predictions at each of these sites based on that data. So they will no longer be based off of a mathematical offset. So essentially, you're going to have more accurate and precise predictions of the max ebb speed, direction, timing, max flood speed, direction, timing, and that slack current timing. So really excited about that. We're in process of getting that done, and hopefully this time next year at your race, I can be showing you updated predictions. And so with that, I just want to say thank you so much to Greg Fisher, who really got me in touch with Randy and coordinated me coming to talk. And thank you to Shay and everybody who coordinated this. As a sailor myself, I wish I was there with you guys racing. It's great. If anybody has any questions, not just about Charleston Harbor, but any of your tides and currents questions, feel free to reach out to me at katiekirk@noaa.gov. Thank you again. Have so much fun this weekend. Cheers.